Hello, my name is Manvir Singh. I'm King Ranjit Singh. My student ID is 241UC2415. So today I'll be presenting our project, and first thing I'll be presenting our output. So when I run the code, it's running. Yeah, so you can ignore this and we can straight go to the log file. So this will be the output for our code, our program. So turn one, we can see the turn is executing, and for each turn, the turn for battleship, it will show where it's at and what it's doing. So it's scanning the area. So from after scanning, it will show its action. The battleship move at this, and then it shot at 77 but hit nothing. So this is the same for all the ships which will be in the battlefield. And then this is the battlefield layout. And so from the coordinates, you can see which ship is at where, and this will be the layout at the end after the ships have all done their actions. Okay. As for the class diagram, so we have the main simulation. So we have the past game file, the simulation turn and delete ship, and then also the main function. So for the ship class, these are all its attributes. And then the methods, we have operators, and then we'll have the look, move, shoot, and destroy. This is where the ship will take its action. So it will look and it will move and shoot and destroy. So the ships we have is frigate, special ship, scout, destroyer, cruiser, and battleship. As for the battlefield, the attributes will are grid, and then width and height. So width of the battlefield and height. So the methods are get grid, get width, and get height. This is where it gets the grid size, width, and height from the txt file. And then it will place the ship in the battlefield and also display the battlefield. Okay, as for the activity diagram, first it will open the log file to put in all the output. And then if there's no log file, then it will show error and stop the program. Then after that, it will open the configuration file, which is the txt file, which has all the next step, which is all the iterations, the battlefield dimension, and team details. Then based on that, it will create a battlefield based on the dimension, and then it will initialize the teams and place the ships, and then it will run a simulation for each turn. So then after that, it goes into a loop. So it will start the simulation loop. It will display the battlefield state after each round, and then it will process the ship action, move, loop, shoot, destroy based on the program. Like what is the ship gonna look at? What is the ship? How is the ship gonna move? How is the ship gonna destroy? Or how the ship is gonna shoot? So then after that, we'll see more. If there are more turns left, then it will repeating the simulation. In this case, we have 100 turns, so it'll go through the loop for 100 times. So after there are no turns left, we'll see if the game is over. If the game is not over, there's no winner, so it will continue the simulation for the next turn until the game is over. Then it will deallocate memory and clean up, and that's all.
Hi sir, my name is Tarunish Nagilmurthy and my student ID is 241UC240NP. Moving on to my part of the presentation, I'm starting with the file reading and initialization simulation settings. So the file reading function, which is basically the pass game file function, where its main purpose is to read the game text file specifically to extract battle settings, team readings, and also ship. So it basically extract the simulation parameters from the file, which is the iterations and the width and height. So based on those data extracted, it will create the battlefield object. So the second one is the place method function, which is for the ship placement on the battlefield. So the purpose of it is to assign ships in position randomly in the battlefield grid without overlapping. And this is our implementation in the code for the place ship method. And next up, the third function is the battle grid initialization function, which is basically the load grid method. So this method's purpose is to load predefined grid data from specifically the game text file. So this is our code implementation for the load grid method. Basically, the function of this method is it reads grid data from the input file, and then it updates the battlefield grid according to the data.
Hello sir, my name is Amelia Janet Edward and my student ID is 241UC240WH. So today I'll be explaining the implementation of concept of teams. So the team class basically is designed to manage group of ships that belong to the same team in the simulation. It stores team related information and organizes the ships for coordinated gameplay. So this shows that how crucial and important is team class to the program. So there are three key features, and the first one is stores team data. It
keeps track of the team's name and number of ships assigned, and number two is manages ships, where holds an array of ship pointers allowing dynamic allocation of ships within a team. And the third one will be memory management, where it ensures proper allocation and de-allocation of ships when the team is created or deleted. So next I'll be talking about the part of the code of this program. So this class theme is basically declared as a class named theme, and public is that the following attributes and methods can be accessed from outside the class. So string name is the name of the team, and this line is basically the number of ships in the team, and this line is a pointer to a pointer of ship objects. So the next, constructor allocating memories for ships. So this team is a constructor initializes a team object when it is created, and this line is initializer list assigns value to name and number ships, and this dynamically allocates an array of ship pointers based on number ships, and each element in ships will later point to an individual ship object. So next is the destructor. So this destructor is called when a team object is destroyed. It frees dynamically allocated memory to prevent memory leaks. This line over here is for the loop through each ship and deletes it, and this line over here, it deletes the array of ship pointers itself. So basically, why is this important? Because if we don't delete dynamically allocated memory, then it will cause a memory leak, leading to inefficient resource use.
So next up is the implementation of Battlefield and also the linking to ships. So the core function of the Battlefield implementation is placing ships, which is the ships will be assigned randomly in the grid, where only an empty grid can be placed to the ship. The next core function is the simulating turns, which is simulate turn, responsible for the 4 main functions for a ship to perform, which is to look at the surroundings, move based on the logic, and also shoot at enemy ships, and also destroy enemy ships with a certain criteria fulfilled. And then also to check the game simulation, whether it's over according to the condition.
Hello, sir. My name is Harvina Dinesh, and I'll start by presenting the main simulation loop. The main simulation loop starts by reading the game.txt file for battlefield settings, ship details, and teams. It then sets the iterations and checks the game status and also the team count. So this is where the main loop begins. It runs while the iterations remain and the game isn't over. So while the game is still running, the next step is the simulate turn function, which is for the ships to move, attack, and scan the battlefield. And after each turn, the battlefield is displayed to show each update. And next, this checks for the condition of the winning team. So if there's only one team remaining, then there is a cleanup of memory and exit before ending the game. So if there isn't, then it goes back to the main simulation loop. And also, if the main simulation loop is not satisfied, then we go to the deleting of the memory and the exiting of the program. So that's the main simulation loop. And next, how upgrade is done in our game is different ships have different abilities defined. So for example, the battleship, the destroyer ship, the corvette ship, and the frigate ship, all 4 of these ships can have the ability of shooting in the game. And next, upgrades are done through the gameplay. So what this means is ships, they can enhance their movement, targeting, and their attacks as they move through the battleship grid. So for example, looking at this segment of code, it shows that if the ship is a battleship or a destroyer, then it has an attack range of 5 cells and it can shoot randomly within this 5-cell range. And lastly is the memory allocation and how we avoided memory leaks in the program. So what we did is we dynamically allocated memory in the program for 3 main components, which are the battlefield grid, the teams, and the ship. So we allocated memory dynamically on heap at runtime for the creation of the battlefield after the user input, and also we dynamically created an array of ships, and each ship is allocated separately. And lastly, in order to avoid memory leaks, we used destructors. So this is to ensure a proper cleanup before the program exits, and also to avoid memory leaks altogether. So this is the destructor and the memory deallocation for the battlefield, and we also have it for the teams and ships. And lastly, in the main function, we are also deleting the battlefield object and freeing the array of team pointers. This is so that the program can safely terminate without leaving unnecessary memory allocated. So that's all from me. Thank you.
So next, I'll be explaining about the use of inheritance. Inheritance is used to define a base class ship and allows different ship types to share common functionalities while extending specific behaviors. In our program, the ship is the base class, defining common attributes and methods for all ships. So this constructor initializes a ship object with name, symbol, team, look, move, shoot, and also destroy. And also, we have used x-1 and y-1 because the ship is not placed on the battlefield yet. So the next will be derived ship behaviors, where different ships type inherits from ship, and override their behavior such as shooting styles, override the shoot function in ship. So the grid, it takes in grid where the battlefield layout, it width and also height where it's the grid dimensions. And this line is basically to control the movement of directions where dx is the vertical movement and dy is the horizontal movement. And this line is to calculate the coordinates based on the current direction. So the third one is extending functionality in battlefield. The battlefield interacts with different shapes polymorphically. So the battlefield uses polymorphism to interact with all shapes regardless of their type. This is the code example using shapes in simulate turn. So the simulate turn function here is to treat is the function to treat all shapes as shapes are objects. And also, even though different shapes behave differently, the polymorphism allows us to call, loop, move, shoot, and also destroy without knowing the exact ship type.
Next up is the polymorphism in warship simulation, where polymorphism is basically allowing different types of warship to execute their unique actions dynamically at runtime by overriding a common interface. So first up is the base class with a virtual function, where basically the ship class is defined as a virtual function, ensuring that all the derived ships implement their own unique behavior. Next up is the derived class implementation, which is the perform action function, where each ship type provides its own implementation. Next up is the runtime polymorphism via the function calls, where a function accepts a ship and calls up from the perform action function. And the last one is dynamic dispatch in simulation loop, where each ship in a team processed dynamically based on its actual type.